All right, good afternoon and welcome to this week's Iowa Learning Farm Conservation webinar. I'm Matt Helmers with Iowa State University and the Iowa Nutrient Research Center and a faculty affiliate with the Iowa Learning Farms. And it's great to be on this side of the webinar today instead of on the hot seat giving the webinar. I get to moderate again this week, and we're really fortunate to introduce a colleague of mine, and I dare say a friend, Dr. Antonio Arenas. Dr. Arenas is an assistant professor in the Department of Civil, Construction, and Environmental Engineering at Iowa State University. And Dr. Arenas, prior to coming to Iowa State, was at the University of Iowa with IIHR, Hydroscience and Engineering. So he's done a lot of hydrologic work in Iowa, and today he's going to talk about some more recent work that he's been getting involved with, and I know super excited about because we had lunch a while back, and he talked about this, but mapping evapotranspiration at the field scale. As always, if you have questions, please type those into the chat box, and I'll get those to Dr. Arenas at the end of his talk. So with that, Antonio, the virtual floor is all yours.
Thank you very much, Matt. So that was a very kind introduction, and thank you everyone for joining the presentation. So the topic of today is mapping evapotranspiration at the field scale. But actually, I deviated a little bit from this particular topic, and I'm going to be showing you analysis at the larger scale, at the state scale as well. So I'm going to start with the basics, and this might be perhaps too basic, but last week on April 18, it was tax day. And I suspect that most of you, and I certainly before that day, we went through the process or hired someone to go through the process on our behalf of keeping track of how much money we brought in, how much money we spent, and how much money we kept in our bank accounts and retirement accounts and things like that. So what those of us working in hydrology go through a very similar process, completely analogous in my opinion, of keeping track of how much, not money, but water comes into a particular area that we are interested in. That's typically what we refer to as precipitation, and it's what the P stands for in this equation. And we also make efforts to gather information on how much water leaves a particular area that we are interested in. Could be an agricultural field, could be a big farm, could be a watershed, a city. And we also try to quantify how much water remains. And that is what the delta S and delta GW stand for in this particular equation. So we make all sorts of efforts to quantify how much money comes in, how much money goes out. And especially, in my opinion, there is one term in this equation, the term that is represented by ET, evapotranspiration, kind of a mouthful, that accounts for the water that leaves a particular area, but not in liquid form, but rather as water vapor. So you can think of as basically the negative process of precipitation. Instead of precipitation, which is the umbrella term for liquid rain, snowfall, hail, any type of water that moves from the atmosphere to the land. Evapotranspiration, as I said, can be understood as negative precipitation, and it's the amount of water that leaves land, goes back to the atmosphere, and is ultimately transformed, and eventually will condense again and will become clouds and will fall as rain in another place. So that particular term is the main topic of my talk today here. And it's been historically, in my opinion, one of the hardest terms in this equation to measure and to actually quantify. And that is up until relatively recently, because there is a project, OpenET, that was launched relatively recently, a couple of years ago, that generated information, satellite-based information, and generated or created a website where basically anyone can get access to estimations of ET, evapotranspiration, at a monthly, annual, and daily scales. So this is a website that I really encourage you to visit if you are interested in quantifying how much water basically our crops are consuming. And I just want to show you really quick how the website works before I go back to this PowerPoint slide presentation that I have for you. And I'm going to show you some analysis that students here working at CCEE did for this particular data. So I'm going to go back now to this website. Hopefully this is gonna work. So Matt, is it showing up the website?
Yep, I see it on my screen.
Okay, thank you very much. So this is the website that anyone can access. All you need to do is to sign up, but there is no cost at all. And it was an effort to quantify the evapotranspiration based on satellite data. As I said, there was a joint effort by non-for-profit organizations, academic institutions, federal agencies, and Google is there as well. And it provides a very easy to navigate platform based on the Google Maps platform, where anyone can go and get information about ET. As of now, in the latest version, it includes, roughly speaking, the western half of the United States, including Iowa, of course. And you can simply navigate to a particular field or place where you are interested in, and you can retrieve information about ET calculated at a 30-meter spatial resolution, so 30-meter by 30-meter squares, if you want. In the current version, as you can see here, the field option, so the option to visualize estimations of evapotranspiration at the field scale integrated, is not available for Iowa, but the raster view is, which is what you are looking at here. And as you do typically in one of those maps applications that we use to, I don't know, when we are traveling or moving around, you can navigate to whatever field you are interested in. Say this is southwest of town, a lot of potholes there. Activate the raster view and simply activate this option that says draw a polygon and run a time series analysis, and you will get information about ET estimated with their methods. You can select the whole calculation is based upon 6 well-established methods to estimate ET based on satellite data and other remotely sensed data. Here you are looking at ensembles, so basically the average that they calculated with the information predicted by each one of the models after disregarding outliers. You can also access information about precipitation and other information relevant for ET. And the information can be also presented at a monthly scale in this case, cumulative in this case, daily, and can also be downloaded, for instance, as a CSV in a spreadsheet in Excel and do calculations. So currently they have data available. Let me see. Data available for 2016, even though it's showing 2017, but 2016 is available as well to 2022. And my understanding is that their plan is to update this with 2023 data very soon. So what I want to show you now is analysis that some students here did working with this data. And this is the first slide that I prepared for you. And it shows basically my check or test of how that particular data from OpenET compared against other hydrologic data that I'm familiar with here in the state of Iowa. So I understand that this OpenET data, estimation of actuality, went through a very thorough and rigorous process, but I decided to test it with my understanding of the hydrology of the state. And what you are looking at here is some calculations that my students did for the Iowa Creek, the 200 square mile about watershed that drains to Ames. And I'm showing the results of my estimation, of their estimation actually, of annual runoff by creating perhaps the simplest hydrologic model possible. And it is simply saying that at the end of the year, if you accumulate all the precipitation and you subtract from that value all the OpenET data, so actually evapotranspiration, that should be equal to the flow that we saw at the stream. And there is a US gauge at Ames. So, and I compare those data, and that's what each one of the dots here represents. So years from 2016 to 2021, so 6 dots, 6 years. And what I'm comparing here is the runoff estimated with the USGS gauge data in situ measurements at Ames, and the runoff estimated with my simple hydrologic model, if you want. I did it for multiple areas throughout the state, and we found out that at this scale, our simple hydrologic model works really well. So at a 200 square miles, something like that, a full year, it is enough basically for water to travel from any place in the watershed to the outlet. However, as we expanded our analysis to larger watersheds, this is the West Niche, Hancock, I think. The agreement between our simple hydrologic model, perhaps is a stretch to talk about the hydrologic model, the Q equal to P minus OpenET starts to not agree that well with the USGS gauge. But overall, so I can report that, and I'm not surprised by that. That was my expectation, that OpenET data agrees with what we understand of the hydrology of this state. And now I'm going to start showing you some results that were generated, images, some time series that were generated using OpenET data. So the first one is at the field scale. So this is a section a little bit west of Cedar Rapids in Linn County. So that shows 3 different land covers. So corn is in yellow, the green is for beans, and the pinkish one is alfalfa. So even though alfalfa is not uncommon, I saw this as an interesting result to share with you, since alfalfa has significantly greater transpiration for the most part. And I aggregated here, or what is aggregated here, is the cumulative evapotranspiration estimated by the OpenET project for the particular 3 land uses that I'm presenting here. And you will see throughout my presentation that this is typically the case. So according anyway to the OpenET data, we have corn evapotranspiring a little bit more than soybeans, not much, typically in the order of 1 inch, 2 inches, sometimes even less. And another thing that I want to say is that even though I know that corn was not there in January, February, March, and April, I asked my students to make all the aggregations using calendar year, so the January to December. So what I'm calling corn here are basically acres where corn was planted sometime in late April, early May. So this is what I have for this particular very small scale. And you see the resolution here on the middle panel, or the tiny pixels, red and green. That's the spatial resolution where you can get information about ET from that website that I presented earlier on. This is just for the year 2020, and most of my analysis, all of the analysis actually that I'm going to be presenting, are cover data from 2016 to 2021. And we're done on Google Earth Engine, which is not quite a website that I presented before, but is a platform that allows you to access OpenET data and many more data sets, and combine them and analyze them programmatically, so by writing a couple of lines of code. So this is data aggregated at the county level, and I asked my students to just choose Webster County and extract out of the land use data for 2019 acres where the crop data layer show either corn, which is in yellow again, and red, which is soybeans. And once again, for this particular year, at the county level scale, we have corn evapotranspiring a little bit more than soybeans, but again, so something in the range of 550 to 560 millimeters. So, and apologies for that if you are more familiar with inches. So the raw data is in those units. So we could have transformed it, but I'm going to be presenting all the information in millimeters, and to do the transformation, all we need to do is to divide the millimeters by 25.4. So, and this is the state. This is the state level data. So, as I said, so we have data for through Google Earth Engine from 2016 to 2021. And something that I noticed in that tiny section in Linn County, and then in Webster County in central Iowa, was the total amount of evapotranspiration at the end of the year from corn and soybean was about the same, different years, different places. So I wanted to take a look at the entire state. On the left-hand side, you are looking at evapotranspiration for, precipitation from 2018. So those of you who were around here may remember that it rained buckets that year for many places in the state. So it's the wettest year in the record that I have access to, 2016, 2021. And on the right-hand side, again in millimeters, I'm showing the total evapotranspiration estimated from OpenET. So you see that, ET varies, but it doesn't vary as much as precipitation here on the left-hand side. I also ask my students to basically produce the same information, and I'm going to toggle back and forth just for you to see the variation between precipitation and open ET or actual ET for the driest year in the record in the 6 years that I presented before. And you see a lot of variation for the map on the left-hand side. I'm going to kind of go back and forth. This is the wettest year, a lot of blue, 1,300 millimeters, something close to 51, 52 inches. And not the same level of variation in looking at the colors on the right-hand side, which is the estimation for evapotranspiration. You see how dry the particular year 2020 was for the western part of the state, where only about 400 millimeters, which is 15, 16 inches of precipitation were received. So and in this particular area, Western Iowa, we see that the actual estimation of ET is more on the yellowish colors, or even sometimes even green, meaning that for this particular year, the estimation of actual evapotranspiration was higher than the amount of precipitation received for some areas. And then I said, well, so I've noticed that precipitation appears to vary a lot, and that was just kind of my observation. Whereas ET doesn't appear to vary as much, at least over annual integrations. So I'm presenting here the coefficient of variation, which is a metric. It's the standard deviation of the data divided by the mean. It's a metric for how different, if you want, 1 year of data is from the next year. So, and if for instance, if evapotranspiration was exactly the same from 1 year to the other, you will see dark green, meaning 0. But if there is a lot of variation, you will see reddish colors. As you see in precipitation, especially for northwest Iowa. So in other words, what this data is telling us is that over the 6 years that I'm presenting here, or that we're used to calculate this coefficient, northwest Iowa has gone from dry to wet year, and swinging back and forth, a lot of variation. Whereas ET overall is more on the greenish colors with significantly less variation in the 10%, let's say 13%. And you can even see here on the map on the right-hand side the effect of the image. So remember that this is model estimation of evapotranspiration, and a model is as good as the data that you use to actually make the estimation with the model. So if there are some issues with the satellite image, cloud cover, and etc., well, those will be ultimately reflected in the estimation, in this case of evapotranspiration. So I guess bottom line here, precipitation varies a lot, and whereas ET, at least according with this data, doesn't vary as much from 1 year to the other. Here I'm presenting a map that shows simply the ratio between evapotranspiration integrated over those 6 years divided by the amount of precipitation integrated as well over those 6 years. And what you'll see here in dark blue are pixels that have either more evapotranspiration than precipitation or close to. Well, so what do we see here in the map? Well, we see water bodies. So we can see here very clear, Red Rock Reservoir and even Saylorville upstream from Des Moines, places where there is a lot of water available to be evapotranspired, and that's why the model is predicting that more water was evapotranspired than the actual water that this particular place in the landscape received from precipitation. The same applies for streams and rivers. But we also see some areas in south central Iowa and in the Missouri River floodplain in western Iowa where there is no clear water body or major river, and you still see some bluish color. So those are areas that are typically, so 3 potential explanations as to why we are seeing those blue areas there. So areas where well, obviously evapotranspiration is higher than precipitation, or close to being higher than precipitation, are areas that are waterlogged potentially, right? So swamps, think about. So are also areas where we have some irrigation going on. So the amount of water that is evapotranspired doesn't come only from precipitation, but some irrigation can be going on. And in addition to that, we can have areas with relatively shallow watersheds, shallow water tables, I'm sorry, and crops can be tapping into those groundwater resources and enhancing evapotranspiration as well. So, and what I'm going to be presenting in the next 2 slides are different versions of this map aggregated using different spatial units of analysis. So the first one is same information as before, the ratio between ET and precipitation aggregated at the HAWC 8 level, once again, 2016, 2021, those 6 years completely aggregated. And you see basically the same information that we were presenting before. And maybe I can offer some ideas about what is going on here, or can tell you what is going on here in northeast Iowa. So clearly in the Turkey, in the Shell Rock, Upper Wapsie, Upper Cedar as well. We see red watersheds. So red here means that those particular areas of the state are receiving significantly more precipitation than evapotranspiration. So roughly speaking, if we go with 0.5 for the reddish colors, the amount of precipitation that they've received over those 6 years is twice as much as the amount of water that was ultimately evapotranspired based on the OpenET data. And conversely, on the other side, so those are wet areas. So, and on the other side of the hydrologic coin, we have south central Iowa and western Iowa with bluish colors. So in those particular areas, we have ET, estimations of actual ET, being closer to whatever those particular areas received as from precipitation. So that would be more on the dry side. Same information as before, aggregated now at the county level. So we have once again, so these counties here in northeast Iowa, Howard, Mitchell, Bremer County, as well. Some counties here in western Iowa, south central Iowa, Monroe, and Appaloosa County, I believe, are these counties here showing dry conditions. But again, so one might take away the wrong message here, because you can say that, well, overall, as far as water needs, we are in good shape, because even in the driest parts of the state, we are receiving up to closer to 0.8, meaning that evapotranspiration is only up to 80% of the precipitation. But that would be basically the wrong message to take away from these kind of plots, because remember that I'm making here long-term aggregations. When we look at what happens inside the year, in January to December time window, well, the story becomes more complicated. But before I go into showing you the plots for a particular year, 2020, which was fairly dry, I want to share with you this paragraph that I basically stole from the 4th National Climate Assessment. So they are about to release the 5th National Climate Assessment. I've read the drafts, and basically the idea is the same. What is projected for the future for the Midwest, for Iowa, is this particular problem that they are identifying here. We're going to have basically a lot of water, precipitation, excessive moisture early on in the year when perhaps we don't like it much. And we are going to have some sort of dry conditions later on in the year where we would like it to have perhaps a little bit more precipitation or less evapotranspiration. So, and that is exactly what happens. That prediction is, in my mind, kind of revealed by the 2020 data in Lyon and Webster County as well. So you see here that for Lyon County, the northwest corner of the state, you see here the time series that accumulates evapotranspiration and precipitation, and actually the same information is presented for the 3 counties that I just randomly selected here. So for Lyon County, around mid-June, early July, we see that the accumulated evapotranspiration exceeded the accumulated precipitation here as well, and that's where the red line is above the blue line. So we had later on in the year, around harvest time, September, October, some deficit. And again, so I don't have a background in agronomy, or I'm not a crop specialist. I don't know exactly how much of a deficit is the one that starts affecting crops. I suspect that some of you will have that background, but it's not hard to imagine that eventually, if this gap between these two lines is too large, well, that would be problematic for crop development. I am presenting here the same information for 2020, the driest year, at least for the western part of the state, for Howard County. And again, so consistent with what I was presenting before, the northeast part, or the northeast corner of the state is really wet. And basically for Howard County, for 2020, ET was never able to catch up with precipitation, and precipitation accumulated was always higher. And that has all sorts of implications, potential flood problems, things like that. And for Webster County, and I could have included any other county, so we have the capability of making these calculations for any year for which we have the data. For Webster County, we see basically something not as extreme as we see it for Lyon County for 2020, but also the red line at some point, the accumulated evapotranspiration exceeded the blue line at around the same time, July, and there was a gap of about a couple of inches here as well. So if this trend continues, having more water early on in the year when we don't want it, and perhaps less water via precipitation later in the year when we do want it for our agricultural crops. Well, so the idea is, or what appears to be clear based on this data and the climate projections, is that some sort of mechanism that will allow water to move from early on in the year to later in the year is going to be needed, at least for some places in the state. And everything falls within the, perhaps in simple terms, under the umbrella of let's slow water down, right? So, but for us to be able to do that transfer of water from early on in the year to later in the year, we do need a place to park the water temporarily, right? When we have it plenty, and then to use it when we actually need it. And there are many approaches to accomplish that: drainage, water reuse, stuff that Matt and Chris Hay at IOSOBIN Association have been leading. We can think about increases in soil health that enhances infiltration, and in that particular case, we will be using the soil as a reservoir to park quote-unquote water. We can think about building farm ponds or detention structures in the landscape, but it's basically that idea that many of the climate adaptation suggestions that I see around always require the final effect of slowing water down to some extent. And I think I'm running out of time. So I want to just leave you with these concluding remarks. So really encourage you to visit that website if you are interested in having some estimations about ET free of charge. Western and South Central Iowa are the areas where ET ratios, the blue areas that I was presenting before, with the highest ratios of ET over P, and the opposite applies for Northeast Iowa. And based on the climate projections, and at least on 2020 data, there appears to be a mismatch between precipitation and crops water demand. With that, I think I'm going to stop here my presentation, and maybe Matt, let you take over information about this slide, and I will be happy to answer any question if anyone has.
Okay. Yep. While we go through these next couple slides, if folks have questions, feel free to type those in the chat box. First off, though, if you need a CCA CEU from watching this webinar, you can earn that and send the following information to Elena Whitaker at her email is alenaw@iastate.edu, and send that by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. Again, alenaw@iastate.edu by 5 o'clock today. You can go to the next slide, Antonio. Okay, if you watch this webinar live, if you'd be willing to fill out this voluntary survey. This is voluntary demographic information that we gather on race, ethnicity, and gender information about people who register and participate in USDA funded programs, and we have some USDA funding for this. You only have to fill this survey out once if you've for 2023. So if you've already filled this out for 2023, thank you very much. If you haven't, if you'd consider scanning that QR code or going to iowalearningfarms.org/survey, that would be great. Okay, and the next slide. Okay, and next week, we're going to look at beaver on the Des Moines lobe, impacts on water quality and sediment transport. Andrew Rupiper, that is a graduate research associate with Dr. Billy Beck's lab, will be talking to us. I think folks will find this interesting. And with that, we do have a couple questions here, Antonio. The first one, I think this is pretty relevant. Do the models account for irrigation practices that may be employed?
Well, the models don't need to account for that. They simply measure or make an estimation to measure how much water via water vapor is leaving the field. So with that estimation, we need to gather more information on if that water was coming from irrigation, it was coming from precipitation, or if it was simply that the water table in a particular area was so shallow and crops were able to tap into that water. So the short answer is no, but that doesn't affect, according to my understanding, the actual estimation of ET.
So I get kind of to maybe ask this a little, delve into this just a little bit more. So if a field is irrigated, we would expect that there's a chance that the ET would be higher for that field than the adjacent field that hasn't been irrigated, if the adjacent field was water limited with the crop production.
That's exactly right. That's exactly right. So the way I imagine is that as if you were standing basically 3 meters above the ground or some distance and measuring however water vapor is flowing upstream, upwards.
Okay. Are there any long-term historical trend data available on that ET to precipitation ratio? Kind of the question was getting at, has this been changing recently?
Well, I didn't, so this particular data started in 2016. So relatively short window to be talking about trends, in my opinion. There are other estimates of ET from other satellite products. I might need to dig more into that. It would be interesting to analyze trends. But we haven't looked into that, but that's a very good question.
Is there any potential to use tools like this to estimate the impact of different cropping systems or cropping practices on ET? For example, looking at cover crop ET values.
And actually, since I was running out of time, I didn't share with you my future thoughts slide. So this is just the beginning. So one thing that I would love, so short answer is yes, right? So something that I would love to do is to receive information from shape files, ideally, of areas that for sure have been implementing cover crops for, at least from 2016 on, and see some adjacent field that for sure has not implemented cover crops, and put the estimations of evapotranspiration side by side. The same applies for relay intercropping, and the same applies, Matt, for the drainage water reuse, right? So those polygons would be really useful. And actually, I have some of them, but we haven't completed the analysis. So short answer is yes. It allows us to look at very small scale variations.
Yeah, so maybe we might even have a couple farmers on here that know they've implemented those, so maybe they could get in touch with us to think about that as well.
I would love that.
Okay. And one more here. Has there been any change in evaporation since the dams were constructed on the Missouri River in South Dakota? Any?
Well, so I'll limit our analysis to Iowa. So data, with that said, data is there to answer that question, but I stay within our state boundaries. So, but the data is there.
Right. If there aren't, we think that's it for the questions. I think this is really useful information and can help us in the future. It's pretty interesting to see where that, where that ratio where it was the highest and the lowest. I guess it was not quite expecting that in Northeast Iowa. So kind of interesting to see. I know there were a few years in there that were pretty wet as well, up in Northeast Iowa that may have influenced the denominator a little bit there. So interesting. So Antonio, I'll give you the last comment if you have any parting comments.
Well, ET, even though we don't see it, is the second largest component of the hydrologic cycle. So roughly speaking, it amounts to 2/3 of the annual precipitation. So it is key for water resources planning, irrigation, agriculture, flooding, droughts, etc. So I really encourage you to take a look at that website.
I think it was, darn, I just said you got the last word, but I'm going to make a comment because it was striking to me that one field, that one section you showed that had corn, soybeans, and alfalfa, how much higher the ET was in that alfalfa. That really does illustrate our land use can impact the hydrologic cycle and how much is going to the atmosphere, and then would be reducing the potential to reduce how much water is going downstream or leaching losses, so forth.
That's correct.
All right. Thanks everybody for attending today, and hope to see you on next week for Andrew Rupiper talking about beaver on the Des Moines Lobe. So with that, thank you very much, everyone.
Thank you.